Hello, and welcome to 5-Minute Math. Today we are looking at the geometric concept of distance formula, specifically how we can derive it, and we will do it in 5 minutes or less. So if we have a line here, MN, and we want to know what is the distance here, what is the length? Well, it's really easy for us to think, well, we could just count the diagonals. We can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. And we might think MN equals 9. But we would be incorrect because the diagonals are actually a little bit longer than the actual sides. And so we can't just count the diagonals. And sometimes the slope isn't exactly 1, and so the diagonals wouldn't even work. So how can we actually count the distance from M to N? Well, what we need to do is we need to remember what we learned about the Pythagorean theorem. So remember the Pythagorean theorem has to do with right triangles. And that lets us know that we've got two sides. And if we square both sides, that's going to be equal to the square of the hypotenuse, or the third side. So let's get this. A squared plus b squared equals c squared. And so we're going to make a right triangle. And I'm going to just extend M over to the right. I'm going to extend N down. And I'm going to create a third point, and this is going to be point L. And it's a right triangle because it means at 90 degrees we have a horizontal side and a vertical side. So what the Pythagorean theorem tells us is that if we have, let's call one of the legs A, we call the other leg B, both of those squared added together equals that C squared. And it's that C that we want to figure out. So how could we figure out this A side here? Well, A side, if we look at our points here, we see that point M is -6, -5, and that we see that point L is 3, -5. So really, what we're doing is we're simply changing the x value. The y value stays the same. Okay, so let's see what A is. So A is going to be, I'm going to take my x value, and I'm going to call this x sub 2, and I'm going to subtract x sub 1, and we're going to see what those two are. Okay, and so I'm going to say my x sub 1 is going to be 3, my x sub 2 is going to be -6. You can put them in any order. So we'll say -6 minus 3. Okay, so what we're going to end up getting is a -9, but distances have to be positive, so we can take the positive absolute value of that, right? And we can say, all right, that's going to be 9. So this is a distance of 9, A. Let's do the same thing for B. Now B, you notice that the x value stays the same. We're at 3 both times. So we're just changing the y value. And so we need to take the y value of 1, subtract it from the y value of the other. And let's do the same thing. We're going to take 4, take away, and then -5, which ends up being 4 plus 5. And so that is going to be 9. Okay, so we do have that distance away of 9 for each of those. So if this is 9, so if a squared plus b squared equals c squared, then what we did is we can say it's 9 squared plus 9 squared equals c squared, or we can say 81 plus 81 equals c squared. And how do we get rid of that c squared? Well, we take the reciprocal of that, and that's going to be the square root of c equals the square root of 162. But how did we get there? Well, how did we get this a squared and this b squared? We got those 9s. So we took the x sub 2 and we subtracted x sub 1 from that, right? And then remember we squared that because that's where we got that a from, right here. And then we added that to the same thing, y sub 2 minus y sub 1, and we squared that. So I'm going to replace this a squared and b squared with these two values. And then remember, if we want that c, we ended up having to take the square root of that, and that is the distance formula that we use. And in case you're wondering, that square root of 162 is about 12.73, much larger than 9. That's why we use the distance formula.